I think probably the most useful thing to keep everything abridged, to focus on when we open up a discussion about machine intelligence is just trying to understand the context of what precisely we're discussing when we say machine intelligence. And we'll get into the details in just a few minutes. But the best way I've heard it described was from a company that we had been in conversation with for a long time. I won't name the company because we're still in conversations with them. But the founder had said, if you think about the IT revolution as it's progressed over time, over the last 30 years or so, the most important change, the fundamental thing that drives all of the applications that we use today is the idea that the cost and the difficulty around communicating information has eventually or continues to go to essentially zero. If you think about everything from email to Uber, applications that we use today are fundamentally arbitraging the decreasing price of communication. Uber is an example of being able to instantaneously on a mobile device understand identity. I mean, you have an identity, the driver has an identity. Identity is tied to payment, being able to communicate in real time the location. All of these things, they're all communications oriented. Now that was the first part of the IT revolution. And the founder went on to say the second part of the IT revolution is intelligence, where you are not just equipping machines to be able to assist with communication, but you're actually allowing the machines to better understand the information they're communicating, understand the data they have in storage. And as you start to do this, you're not just making communication a commodity, but you're actually making interpretation and intelligence that happens on top of that information a commodity itself. I guess I should probably introduce myself briefly. My name is Prescott Watson. I'm a principal here at the OurCrowd investment team. And as you heard in the panel, if you were there, machine intelligence is one of the themes we focus on quite a bit. We're not unique. I think probably every VC you say will say machine intelligence is a focus of theirs. But we're not lying. I mean, machine intelligence is really the second big wave in the IT revolution. And that's why we're all here today to talk about that. Unfortunately, we are missing one individual. Hopefully, he'll be able to join us in the middle of the panel. But I'll start from those of whom are joining us right now. Closest to me, Dr. Goren. He is the head of Tel-Aviv University's Curiosity Lab. And his focus has been on machine-human interaction. He has a lot to bring to the table about not just the applications that are being enabled by machine intelligence, but also some of the changes that have allowed those applications to come to fruition. Next to him is Dor Skuler, the co-founder and CEO of Intuit Robotics, one of OurCrowd's portfolio companies. For those of you who will be staying, I highly encourage you not to miss the Intuit Robotics demonstration that's going to be happening shortly in one of the plenaries. It's the world's first demonstration of LEQ, which is their premier product, a machine, a robot that will aid the aging in place demographic by allowing easier communication in home. So Dor will have a lot to say about how he's able to, and how his team is able to help LEQ do what it does, and how machine intelligence is a core part of that. Next to Dor is Elad Benjamin. Elad is the CEO of Zebra Medical Vision, a company that is very fitting to what we had just described, taking information and not just communicating it, which would be teleradiology, where you're able to send CTs or MRIs or X-rays between a point of care and a doctor far away. He's going to the next step, the second level of the IT revolution, actually applying interpretation. Zebra Medical Vision is able to interpret, eventually, today assisting, eventually even perhaps supplanting human radiologists by performing the critical interpretation tasks. And the last person on our panel here today is Alain Tiquet. He is a group director at NVIDIA. He's been there for well over a decade and has therefore had a tenure at NVIDIA that has seen NVIDIA's stock price skyrocket, largely because NVIDIA is at the center of the machine intelligence revolution. For those of you who aren't familiar, NVIDIA is a chipset manufacturer that focuses on massively parallel computational power, GPUs. And these are the very items, the very computational devices that allow a lot of the machine intelligence processing to happen. So I think we have a great panel today. It's going to be a little bit shorter than we expected, but I hope that it's going to be an interesting conversation. Now, just for technicals, would you mind picking up one of the microphones to make sure that these actually work? Okay, it looks like we're good. So I'll come sit with you. Maybe pass that microphone down. Please. Thank you. Hello? Okay, it works. Perfect. So we figured that it would probably be smartest to kick off this panel, because we have a mixed audience here, not talking about a lot of the technology behind what's enabling the renaissance or the acceleration in machine intelligence, but first talking about the applications that are actually enabled by the increase in machine intelligence. And all four of you come from different vantage points to this question. So I actually wanted to start with you, Dor. LEQ ranges the gamut from interpreting inputs to recognizing people to learning behavior of humans using a lot of techniques that have been core to the rise of machine intelligence. So could you talk a little bit about what sort of applications specifically are enabled by this rise, and what's different today than it was about, say, 5-10 years ago?
Sure. There's a lot of background there. Can I switch mics with you first? Thank you. Yeah, so as Prescott said, basically LEQ is active aging companion that helps older adults live a more active lifestyle and stay engaged. And the way we do that is combining machine learning, which you mentioned. We learn the preferences, we learn the likes, we learn how it should behave in order to build an emotional bond and help change the behavior of people. But there's another part of it, which is cognitive computing. You know, a lot we talk in the machine learning space or in the machine intelligence space about learning, which essentially is pattern recognition. You teach a machine to identify something, and then you give it a new image or a new input, and it will try to tell you if it's what it was learned how to do. The other part that we put in, which is very interesting, is cognitive computing, which is basically based on that input. LEQ makes up its own mind autonomously on how it should behave. So for example, if the goal is to get older adults to be more active and engaged, we need to get them to be more active and engaged, right? So we need to suggest activities to them. This is especially important in the elder population because they tend to be more reactive than proactive. They tend to stick to a routine and repeat that routine. But if we want them to change that routine, we need to suggest activities to them. So based on all of this, basically, the machine sees and hears what's happening at home. It tries to understand that, turn that into context of what's happening at the home right now, and then based on machine intelligence, of the cognitive computing, actually suggest activities like saying, hey, why don't you go for a walk? It's a nice day. Or, hey, how about we listen to some Frank Sinatra? So we don't wait for the older adults to ask to play music, but the robot wakes up and suggests to listen to music, or to read an audiobook, or to take their pills on time.
So Gordon, you and Dor have a close relationship because of Intuition Robotics. Photo op. So maybe could you talk a little bit about what you are doing at the Curiosity Lab that has helped enable some of these better machine-human interactions?
Sure. So the Curiosity Lab, we're actually developing algorithms that simulate the curiosity of people. So we study how people and children are curious, and they learn about their world autonomously and explore in an optimal way the world. And then we implement this in robotics. And in Intuition Robotics, what we actually want to do is to study the elderly with LEQ, and to do it in an optimal manner, to personalize the interaction, but to do it very fast. You don't have, again, like other machine learning algorithms, you don't have 10,000 or 10 million samples to start to learn from. You need to do it very, very quickly and very robustly and very personalized to that individual. And then we're using these algorithms to actually do it in a social way, and also in a very optimal and very fast way.
Interesting. I just want to also point out that Michael Radwin was able to finally join us. Thanks, Michael. Michael's the head of artificial intelligence and machine learning at Intuit, which, for those of you who aren't familiar, is one of the biggest financial services software companies in the world. We'll get to some of what you're doing in just a few moments. One of the things you brought up, which is that in the case of LEQ in particular, you don't have access to that much information upon which to train and to learn. That kind of touches to one of the enabling factors that helped accelerate the rise of machine intelligence, which is just greater access to information. Elad, I think maybe this would be a good point at which to transition to you, since the rise of the ability for Zebra to do what it's doing is largely predicated on your academic partnerships to access large data sets. Could you sort of talk about how that's helped you?
Sure, yeah. So at Zebra, we're essentially taking a computer and trying to teach it how to automatically diagnose a medical image. All of us at some point, unfortunately, have had a CT, X-ray, MRI, etc. And today, those studies are sent to a radiologist who, in turn, needs to perform some sort of diagnosis, after which care will continue. The visual world, or interpreting the visual world, has become much, much better over the last few years, and in part largely due to data. And the premise is that if you give a software module tens of thousands or potentially more examples of a particular finding in the body, that software or that neural network will learn what are the features that make up a particular finding versus another finding. And then, you know, when you feed it example number 10,001, it will know how to classify one finding versus another and give you an accurate diagnosis. And so the challenge here is within the world of healthcare, and specifically imaging in healthcare, it's very hard to get your hands on enough data in a structured way in order to be able to feed those networks in the first place. And some of Zebra's strength has been the ability from the very beginning to essentially partner with a number, quite a large number of hospitals and institutions, which essentially gave us access to anonymous patient imaging data, which in turn allowed us to teach our networks. And we continuously do so. For every new finding that we want to generate, we have to mine through millions of patient records, find the relevant pieces, feed them and teach the network, and then you go on to the next finding, et cetera.
So what you just mentioned there, that the information itself is extremely valuable to allow you to do this, that sort of gets to another point, and it's not machine intelligence itself, but it's rather some of the consequences of the rise of machine intelligence. The value of data, and the fact that a lot of businesses who 10 years ago would have had information that they didn't really care that much about, even sometimes would discard after regulatory requirements expired, they're now keeping that information. They actually realize there's a lot of intelligence that can be generated from that information. So I think both Alain and Michael have what to say about this in respect to both of their businesses. But let's actually start with Intuit, since of all the companies here, perhaps Intuit's the one that's sitting on the most information that it directly touches itself. I mean, Zebra, you guys basically partnered with academic institutions to get access to this information. But Michael, what are you at Intuit doing to try leveraging the data you're controlling?
Sure. So our products that help consumers deal with filing taxes or managing their personal finances, and also small businesses. And so for years we've been using this data in small ways to help, for example, catch mistakes that a small business might make. So if you buy a notebook or some paper for your printer, that you should treat that as one kind of expense, but if you buy a truck, it's a depreciable asset. And QuickBooks, the small business accounting product, tries to make it easy so that you don't need a bookkeeper, you don't need an accountant. But of course, when it comes time to filing your taxes, it actually does matter. And so this large collection of data where other businesses like you have taken this action, but somehow you took a different action, we're able to use this outlier detections technique that helps you to actually fix the errors so that you can end up delivering the most correct tax results to the small business. And a similar thing we do in TurboTax.
But why wouldn't that be possible just with setting up rules, saying if you're buying a truck, there's something like, can you explain why?
So it is possible with rules, but it's incredibly labor intensive, and people use different names for different things. So this is where natural language, which is one of the subfields in artificial intelligence, comes in. You might call it a vehicle account. I might call it a car account or a truck account. It might be Bob's truck and so different names get used, and we need some ability to actually use the language to be able to extract the actual sort of latent meaning behind it. In the tax situation with personal consumer taxes in the U.S., it's a similar situation where you could interview a CPA and come up with a set of rules like, oh, people over this age tend to have mortgages, and so therefore they should get this mortgage deduction, and people over this have, or in this situation probably have kids, and so they should get this. But it turns out that when you have tens of millions, or actually in our case hundreds and hundreds of millions of tax returns, you don't even need to interview a CPA. The answers are actually there living in the data, and we just observe, well, this is what people did in Kentucky versus this is what people did in California, and we actually can match that up with the actual rules and regulations, and we know what people's actual behavior is.
I think that brings up a question that we'll get to in just a moment, which is, what are the consequences of making decisions based off of models you've created from past experience? But before we get to that, I figured because there's so many applications that are leveraging NVIDIA technology, Alain, it would be good to hear sort of like a brief overview of what some of the most interesting applications that you've seen in your years trying to help promote this ecosystem.
Yeah, we see a lot of different things in the health. One interesting thing on the robotics. You are talking to the aging population, and at the opposite, I've seen in China, a robot talking, educating kids. So it goes, from all your lifespan, in terms of application in robotics, and there are a lot, And what is interesting is that, and what is good is that people don't try to solve everything with a single robot, and go, step by step. And this company in China just focused on kids in between 5 and 8, because they have a limited understanding of their language, or of their, their abilities and so on. And this is very interesting to see these kind of things. There are many applications in the health environment, everywhere in all countries. One thing, I would like, was scary to me, a few weeks ago. I met with a law firm, and this law firm was telling me we start using artificial intelligence. When we have a case, we scan all the cases, similar cases, and try to find out, what the output is going to be for our case. And on top of that, what is scary, they said, we also scan all the judges and locations and try to find who is the best judge for our case. Try to win.
I mean, this would be happening anyway if they had enough staff, right?
Yeah.
It's just the idea that you
It's a
take
question of time.
intelligence, the cost of intelligence to zero, and you have a whole range of things you can do that you just couldn't do before.
Yeah. So this is really where, so we see a big area of applications, and everybody talk about a lot of data. So this is really the key thing. It's data, and is to make transaction decision and as accurate as possible. And for that, you need very deep neural network, and everything is possible only if you have enough power. Computation power. This is what you need, and AI has really been taking off, in the last 3 or 4 years, because people get access to GPU technology and can do that, and this is really where it makes a difference. So everything I see is very interesting. It's very difficult to say what is best, and at the beginning, it's always difficult to understand what is going to be significant and valuable in the real life, and it's going to take some time. People will try a lot of different things, and I think this is what's happening now. What is going to stay is going to take a couple of years, before we really understand the value of AI.
I mentioned before that one of the things we wanted to discuss were some of the consequences of the rise of machine intelligence. And Michael, you had brought up the fact that they're now important, not decisions necessarily, but you have to decide when to alert someone or when not to alert somebody. And if a machine is tasked with that, even if it's trained well, if it's not based on a rules-based system, sometimes it can be difficult to explain why the decision came out the way it did. I guess I'll start with you, Elad, because this seems like the most obviously mission-critical type of industry to be in. And obviously, you're working within the existing regulatory framework for medical devices and decision support systems and things of the sort. But in the future, as you start to eat into the radiological market, how do you think people will handle decision-making being done by software?
Yeah, so it's a good question. We get asked all the time, are you going to replace radiologists? What, are they going to be around? I think sometimes I compare this to the aviation industry. 20 years ago, when the first autopilots started coming out to market, you had tremendous resistance from, pilots and companies saying, how can you possibly, surrender such a complex task as flying an aircraft to a piece of software? It's going to crash planes, it's whatever. Today, I don't think anybody would get on a plane if they knew there wasn't, an autopilot on board. And I think that's in some cases where at least radiology and some other areas in medicine are going. We're going to reach a place in a few years where the assistant is going to be strong enough and accurate enough and fast enough that we as patients and the physicians as well are going to trust it most of the time. But you're still going to need people there to just make sure that the aircraft is still going in the right direction. If things screw up, you still have somebody with good enough experience and knowledge to potentially overcome whatever the software errors. So right now we're at the beginning of that. So it's still, the decision-making ability is very, very much in the hands of the physician. But over the next 5 years, that shift is slowly going to move towards these digital assistants and automated analytics tools.
This is kind of an open question for whoever feels most comfortable taking it, but will there have to be changes in the way liability is perceived and the way the legal system deals with critical decisions? Not just in whatever particular verticals you all work in, but just in general with the rise of independent non-people making increasingly complex decisions.
So one of the challenges we're looking at, by the way, it's really interesting, I think, that the technology is less the problem of all of this. It's about people's behavior and about how we want to deal with it and what we expect, what we accept. One interesting dilemma we have.
Like the embarrassing photos people keep posting of me to Facebook.
Exactly. Exactly. So one real dilemma. Okay, so LEQ has sensing capabilities and it knows what happens at the home. Now, what do we do if we saw that mom always wakes up between 6:30 a.m. and 8 a.m. and she didn't wake up yet, and an hour passed and another hour passed? What do we do? Do we notify somebody? Is it our decision? So, and that's not clear. And if we don't notify somebody, to your question, do we have a legal liability? Because we knew and we did nothing. So we went and, to try to answer this question, we went to ethics legal experts that focus on gerontology. Like, what do we do? And the answer was, what you have to do is interview the older adult before it happens, ask them what they would like to happen in that situation, and then you enforce their wishes, kind of like a do not resuscitate tattoo, right? If you're a paramedic and you go to someone's home and they're not breathing and there's DNR, you're not allowed to resuscitate. And that's the approach we're taking, and it's not ethically clear to me 100%, to tell you the truth, that if we are aware that somebody is, just had a stroke, they fell down, we're aware of it, we're able to recognize that, not today, but let's say we will soon, that we don't have the moral obligation to report on that. But the legal experts say, and I totally understand that, because if I would be in that situation, I would want to be in control. It's all about asking people in advance and letting them create their own wishes, and it's your job to enforce it. Then the question is, okay, if you didn't enforce it correctly, are you then liable? And that's still an unopened question for me, unclear. Yeah.
So I guess moving away from the consequences of problems that arise to how to prevent problems from arising in the first place, there's this whole talk about how do you get machines to communicate something to humans before they make a decision. And the most obvious and visible way this would work would be, if a car is about to turn right, I make eye contact with a driver on the road, right? But in the future, there's going to be cars that don't have drivers, right? So how do machines communicate their intentions and their thoughts about a scenario as the scenario plays out? I think I'd like to hear both from you and Alain, but let's start with you.
So again, in the field of the social robotics, or robots are now acting near people, it's very important to communicate the intent and what is going to happen. So there are actually robots in factories that work next to people, and they put a tablet with a face on it, so they can actually communicate where they look at where they're going to work, in order to infer, to show the person working with them what is going to happen. And also here, when you have an interaction with a robot, with the elderly, the Elico is going to look on what's going to happen, to show the person what is going to happen also in some communication skills. I also work with children with social robots, and it's also very important to show the child what the robot is actually thinking, and what is and what is going to ask, and what is going to come next in the interaction. And having either a face or some communication channel is very important to communicate what the robot is thinking and what is going to happen next.
Got it. I think we do want to come back to these kinds of questions in a minute or so, but let's spend a few minutes talking about the changes that have happened, that have allowed, I won't say the invention or this, because a lot of these techniques themselves are not necessarily novel, right? The techniques to establish intelligent software. But rather the acceleration that's happened over recent years. We spent a few minutes in the beginning talking about the availability of information that's so critical to generate these types of things. Computational power is also very important, and given NVIDIA's role in the rise of this, Alain, if you have any comments about what's been changing over the last decade that's really enabled the acceleration of machine intelligence, we'd love to hear it.
So, if you take the last server we have launched, one server can have over 29,000 cores. One server, and this server, in terms of power, is equal to 250 servers, traditional servers. So this is a kind of power that makes a big difference. You have now about 170 teraflop in one basic server, and you can stack them up. Yeah. And what is interesting to see, and you've probably seen the Facebook, trying to push AI to everyone. And Facebook, the first thing they did is to put a server available for for anybody who wants to do some work on AI. This server is called Big Sur, and inside they have 8 new GPUs. So I don't know what kind of GPUs they have, but again there are thousands of cores, and this is what makes a big difference, because there are a lot of data, a massive amount of data, and you want to crunch them as much as you can to get as accurate as possible. So this is what has been changing in the last 5-10 years. So you put this plus some software to run everything, then this is where we are.
I think there's, if I can add something, I think we haven't seen anything yet, and the reason is, I can tell you in the last year, the very big difference we felt. We started doing this ourselves, buying servers, trying to figure out how to ingest data, how to deal with it, how to maintain an engine like Tejano to do the crunching, et cetera, et cetera. And then we were invited by Google to be part of their machine learning service, which is a cloud-based service that ingests all the data automatically, like huge amounts of data. If it's on Google Cloud, if our database is on Google Cloud, you can run machine learning on it. All the maintenance of the engines and so on are just done as a service. And the ability to just start learning immediately just lowers the bar to the point that you can just start playing with data immediately in the ways that you're not limited, not by the amount of data, not by the amount of computational data that you want, and not by the ability to experiment and move features around, move the type of information you're looking at as you're trying to find your way, what's really important. And I think as you lower the bar, you're going to have many more people able to do this. You still need data scientists. You still need to know what you're doing. But it's just so much easier at scales that we as a startup would never be able to get to quickly or at all, that I think that is going to allow us to see learning and machine intelligence everywhere much quicker than we thought before.
So I'll also add, 20 years ago I was at Yahoo doing early experiments in ad targeting, and we were using single layer or single hidden layer neural networks. We wrote the code in C. It was like, and it was a mess. We were able to deliver amazing results, but compared to where we are today. And so I saw three really big changes technology-wise, and I want to just touch on, I think there's this fourth change coming. And so Moore's law really made parallelism possible, and so we have things like GPUs that we didn't have 20 years ago. This has been a huge improvement. We have the parallelism that's actually, we have better open source tools so that you can actually build software in a way that can actually take advantage of the underlying hardware and parallelism. And the third thing is that there's just much more data. If you're trying to solve a problem and you only have 1 million data points, you can do it, but if you have 100 million, that may sound like it's a burden, but actually it's often an advantage, because the more data you have access to, often the easier it is to detect the subtleties and the patterns. But really, you do need data scientists, and you do need these sophisticated tools. And what is coming next, and it's still very nascent, are these cloud AI and machine learning services, which sort of brings it up at another abstraction layer. And they aren't mature enough yet to really use for every application. Sometimes, in our case, we have this highly sensitive financial data, and because of regulations, we can't just put it plain on the public cloud. And so, as we see advancements in the sort of the cloud computing and these abstractions and better APIs, it's going to become more democratized, and we're going to see it across many more industries. And I don't think the data scientists are going to be out of a job, just the same way that the radiologists aren't out of a job, but they'll have much more powerful tools and will be able to make a much more profound impact.
You talked about the three sort of the pillars that are required to generate intelligent software, right? You have the data pillar, you have the computational power pillar, and the approaches you take to that. And the third is, as you pointed out, many of these are now open source, available to anyone. The approaches you use to run the models, or to generate the models, right? And what's funny is that with all three pillars, different players in the technology ecosystem have erased the advantage that each one of these three pillars creates by open sourcing something, right? So Google, which has all the data is its barrier. It open sourced the approaches you need, right? NVIDIA's advantage is the computational power. And this is rapidly going to zero, but NVIDIA is managing to stay ahead by releasing increasingly powerful machines all the time. Right now, the only thing that seems to be truly uncommoditizable is the data access itself. So I guess to anyone on the panel who wants to comment on this, how does this change the way that enterprise value is built? I'll give you an example. IBM picked up Merge Healthcare, I think less than maybe a year and a half ago, for several $1 billion. And Merge is a great business for a lot of reasons, but one of the main reasons it was such a valuable acquisition was that it has tremendous access to patient information that would be relevant to Zebra, for example. What happens when I'm generating data for a business, and that business is able to make value off of that? Does that ever flow back to me, the consumer?
It's a good question. In healthcare, for example, there's a lot of questions around that. Who owns the data? Do the patients own the data? Do the hospitals own the data? But I think that over time, data will be available. It'll stop being a barrier. There's some niches and systems and markets where it's still cumbersome, but over time, data will be available. I do think, however, that knowing how to interact with that data will still make a difference. So even though everybody's using some form of machine learning framework, whether it's Google or Café, whatever, smart people are always able to generate more from additional tools. It's just like having a programming language and saying, well, everybody knows how to program, so there's no barrier, but that's not true. We see innovative approaches to working with the data all the time. And I think that's still going to be what gives companies a competitive edge over the others. Yes, two companies may have similar data and similar tools, but how they use them, how they combine different technologies to create, in our case, we measure ourselves on the accuracy of our algorithms. If we want to detect a disease, how accurate are we? And the difference between 80% and 85% and 95%, in some ways it's the data, but in many places it's, who are the people that are doing the analysis and how are they using the tools in an innovative way to make that leap? So I think that'll still remain a barrier.
I think another thing that to consider is the sort of the privacy and the ownership of the data. To sort of elaborate on this point, as with health data, financial data is very, very sensitive. People want to feel ownership of it, and this is one of the things that we figured out many, many years ago, that you have to tell the customer, and really it has to be true. It's not our data; it's your data. You own your data, and you get to do with it what you want. And so we're going to try to use your data to make you happy, to do things better for you. But at any point, if you want to take your data with you, or you want to give us certain terms or conditions, we actually have to respect that. And I think this is going to be a differentiator, is that as businesses are collecting this data, they've got to be really, really clear about what value they're going to deliver back to the end user, or they'll choose a competitor who has a better data stewardship, data privacy controls.
Interesting.
One thing I would like to add on the data, you are right, you have a lot of data and so on, but what is also very important is you have to keep up with the data. It's not one image in the time. You have to update your data, to feed your data on a daily basis, because the world is changing. And this is very important to keep that in mind, that data is not something, it's not a photograph at one time of your data. You need to update it on a regular basis and keep learning and training your system. And this is really something that you have to consider when you do AI.
Michael, you were just talking about how you need to make sure you're transparent with users about what's happening with your information. I think a lot of us, the first thing we think of is, I don't want private information to be released to people. I don't want to know about my private information. I think we're all talking about another challenge in relation to that, which is that if I give my small amount of data to this company, and that company aggregates a bunch of things, my data helped that company make better software. So am I going to see something in return from that? Like when you buy a Tesla, you sign up to a service level agreement that allows them to use the information off of your car to make their cars better. And people are okay with that, because in exchange for you pitching in, you get some value back. But how does that change the customer relationship when everyone wants to get customer level data to improve their services?
And in our experience at least, which is not long, there's a very big difference between enterprises and consumers. Enterprises have liability to think about, and they have continuity to think about. When you ask a consumer, do you want your data to be private? Absolutely. When they download an app and that they see value in, they don't even read the terms of service, and they press accept. And they share with Google all of their emails, and then you send a WhatsApp to somebody about a movie, and lo and behold, you log into Facebook and you have an advert for that movie. And that happens right now on your phone if you go and do that. So I think your point on value is crucial. I think people are willing to part with their data if they trust you, and if they get very clear value in return, or if it's just something cool and they don't think twice about it, which happens more often than not.
I think that's how Tesla got away with it.
But I think it's the owners is on us to make sure we firstly need to deal correctly with privacy, with security, and regulation is an interesting bar that of course you need to meet, but you really need to think about it from an ethical perspective. How would you want your data to be treated? But the other part of it is make sure you really add value to people. And it goes all the way up, right? Because people might share data with us, so LEQ can make them recommendations and help them age and all of those things. But we use machine learning services from Google, like speech to text or like NLP, and we use image recognition services from others, and they get that data from us, and they learn from that as well, and it keeps on going. They probably have vendors themselves, and they put it on their cloud, and they get data from them. So you really have to act responsibly as far as anonymizing data, trying to think if something awful happens, how do you trace back? How do you make sure that small mistakes don't end up being big mistakes?
In the last probably 5 or 7 minutes of the panel, because we have a plenary that's going to be starting at about 12:20, I wanted to sort of take a broader picture about the impacts of the acceleration of machine intelligence on the labor market and on the economy. It seems like in the last year, at least on my Facebook feed, and who knows what that really means, everyone's talking about this concept of a universal basic income. What's going to happen when a lot of even some white-collar work is starting to be automated. Clearly, things are starting to be automated in non-white-collar jobs. But as things progress, what's the role that machine intelligence will play in sort of the upset of the current economic order? It's an open question.
I want to talk about education, actually. I'm working with robotic tutors for both for kindergarten and for school and also for the home. There are a lot of concerns from teachers of what their role is going to be. And here they're actually more it's going to augment all of this because there's actually shortage in the workforce here. In many countries, the ratio from teacher to student is very, very bad. And here the role of machine intelligence can actually help the workforce and augment and make for the teachers or for other such as educators to actually make the work better and not replace them, but actually enable them to make their work even better using these machine intelligence and these social robotic tutors. It's not instead of people; it's because people are actually missing in these kind of markets.
From our side, same question is we get a lot of feedback from people as they get exposed first to what we're doing. Are you going to replace the role of children in caring for their parents? And clearly not. A, it's impossible. B, nobody wants a robot to replace himself caring for his parent. But what you can do with technology is bridge gaps. So there's a distance gap because people live far away. There's a time gap, especially people our age are working really hard. They have to take care of kids and they have to take care of their parents, which is very stressful and they don't have a lot of time. So you can use technology to overcome some of those gaps, but I don't think we're anywhere close to having robots replace meaningful relationships.
The Economist surveyed a bunch of experts as to what the likelihood of certain professions are to be automated out of existence through technology, and accountants was one that was listed at like 94% likelihood, at least among this survey. And actually, at Intuit, we work with a lot of accountants because they help with small business bookkeeping. And one of the things they say to us is actually, I spend more than half my job just doing data entry and this drudgery of fixing these really, really common mistakes that the small businesses make. But what I really want to do is I want to be an advisor. I want to help them to make better decisions. I want to help them to figure out where to get capital or how to manage their cash flow. And so actually AI is going to help to automate the boring parts, but it's not going to replace the really, really interesting parts. So we don't think that you're going to automate, even though 94% of people think, we disagree. We think accountants are going to be around for a long time to come.
Dor is about to go into a really important meeting, so he had to run. In the last few minutes, I know Elad, you seemed like you wanted to jump to the microphone.
No, I think, us that are in this field, I think we're all aware that there's still a difference between what, some of the press and the hype wants you to think and the reality of how long things will take. But I also think it's just going to be different. If you look 15 years ago, more than 50 or 60% of the tech jobs that exist today were not in existence. It's just different. There's just complete shifts in the types of people, the type of education, the type of skills that you need. And I think that's what we're going to see over the next 10, 15 years as well. It's just going to look different. People are going to have different roles within the workforce. They'll still be there, but it's just things that today it's very hard for us to imagine.
I know that in response to the Amazon Go store, a lot of people were initially kind of thinking, I work at a grocery store, and what's that going to look like in the future? First of all, I'm not sure that Go is a future. If you haven't seen it, look it up on YouTube or Facebook. It's an amazing future vision for a store that Amazon's rolling out. They're rolling out brick and mortar retail locations across the U.S. in the near future. A lot of people started to say, well, actually, Go's not going to be everywhere. But even the places it is, what you're able to do is move people away from the sort of the rote tasks of maintaining inventory to the things that do require interpersonal relationships. They're not yet things that robots can do, such as sales or customer support and assistance. So I think that there are a lot of people that have that view. So we have about 15 minutes before the next plenary. I want to thank everyone. I guess Dor left a little bit early, but thank you all for joining the panel. It's a good discussion. We at OurCrowd are really excited about machine intelligence, as you heard earlier in the plenary last time. We already have made a number of investments in the space, including in your company, Elad, and also in Dor's company. And we're going to continue looking at machine intelligence and the consequences it will have in the startup world to make further decisions in the future. So thank you all for joining us.